Okay, so you probably have the idea now of how this flow is going. We're on to our last voice protocol, Media Gateway Control Protocol. And we're going to do the same three things, and that's break down the architecture, the call flow, and the gateway configuration. From the voice gateway perspective, MGCP is probably the simplest protocol to work with. And that's just because it centralizes all the configuration. So this nugget will probably be a little shorter, just because CVOICE focuses right here on the voice gateway, and there's not too much to do. All of the configuration in the MGCP world, I shouldn't say all, most of the configuration is going to all land right here on what is technically known as the call agent. So a little history on MGCP. MGCP, contrary to popular belief, is an industry standard protocol. You'll find a lot of people saying, oh, that's a Cisco proprietary thing, right? No, no, no. It's actually an RFC standard. However, Cisco was heavily involved in creating the standard. Their engineering group was on the board, and they advised. So when it did come out as an RFC standard, almost all the other vendors out there are like, whoa, we're not going to do that, because I mean it's kind of like the competitors of Cisco to take a protocol that Cisco had one of the key roles in developing. It's kind of, I don't know, it's almost like bad form. Like, well, I can't use that protocol on principle alone because it was developed by their competitors. So that's where it got the feeling that it was a proprietary protocol. However, there are a lot of vendors out there that do use it. The structure of MGCP, let me jump right here, is a master-slave control model, to where all of the configuration exists here on the call agent, which we know in the Cisco world is your call manager or your CUCM server. So I can create these centralized dial peers or dial plans, basic configuration for all these gateways, and they all report back and get their settings from here. This makes MGCP very much a protocol that could be used by, for instance, a large deployment or a hosted provider. So, for example, a lot of companies are doing this. The cloud, right? That's the new thing. The cloud, putting your call servers at a data center and running hosted voice over IP. To where these organizations will come to a business and say, hey, we will run your voice over IP system for X dollars a month, and you can replace all your phone lines, get cost savings, all that kind of stuff. And what they do in that kind of environment, they've got, let's just put hundreds of customers here, is they will install a voice gateway at the customer premise, and that voice gateway will have virtually no configuration on it. All it will have is a configuration that says, go here to get your configuration. So from their perspective, it becomes I shouldn't say very, but much simpler than trying to manage all of these separate configurations individually on each one of these. Instead, they put all of their configuration here at their hosted data center, to where everything's reporting back to, and these devices get their settings from there. Very different from SIP and H323, which requires that peer-to-peer configuration where these guys will have a whole group of dial peers. Now, it's not all that glossy. MGCP is great as long as the voice gateway can speak to the call agent. If that communication is good, then MGCP is good. If that communication gets severed, let's say over here we have some backup PSTN lines, maybe some analog or digital lines coming in case the internet connection or whatever connection you have to that data center goes down. Well, in that case, the voice gateway goes, I don't know how to do anything. It loses its mind. It literally is kind of like a mainframe dumb terminal environment. So what needs to happen is we put a backup configuration. This is what is known as that SRST, Survivable Remote Site Telephony. And that backup configuration can be H323. That's the most common. Or it could be SIP. To give that device some survivability should it go down. Now, the good thing about that backup configuration is it's very templatized. You can just make it part of the base configuration. Essentially some higher priority. When I say that, I mean the priority command. So in reality, it's actually lower priority dial peers that are used to just say, okay, if all else fails, if we lose our connection with our hosted voice over IP carrier, then we will, use a basic PSTN dial plan to get out that direction. So you can really template that config so you're not doing all these unique customized settings for each person. A little more about it. It is a second generation protocol. SGCP was the first generation. It is a plain text protocol, just like SIP, to where everything is very easy to see. It is used on UDP port 2427 as a receive side. And this is from the voice gateway perspective. So this guy receives messages from the call agent on UDP port 2427. So firewall admins beware. And he sends and communicates back to the call agent on port 2727. So kind of a little dual port system that it's using for the receive and send from the voice gateway's perspective. And it is kind of a stimulus response system to where when some event happens, the gateway is like, what do I do? Do this. What do I do? Do this. What do I do? Do this. The one exception is the dial plan. So if the dial plan existed solely in the call agent, then every single time a digit was dialed, like let's say there's a phone connected here on an FXS port, they pick up, it's like, oh, off hook, what do I do? Play dial tone. Then he dials a 9. He's like, oh, I've got a 9. What do I do? He's like, wait for more digits. And so it's kind of, it would become just overwhelming with messages if the dial plan wasn't on there because every digit would cause communication. So what happens is when the MGCP gateway links up with the call agent, it actually sends a cached version of the dial plan to the call or to the voice gateway. So it's able to process the call and know what is a valid dialed number and what is an invalid dialed number. However, once the number is dialed, the gateway is solely reliant on the call agent. He's going to say, hey, okay, they dialed 9-1-800-555-1111. What do I do? The call agent says, oh, okay, you want to send that out, your voice port 0/0, it kind of does all that kind of stuff. So centralized dial plan, that's a big key. And this, ding, 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 this is a unique feature. Supports QSIG for working with PBX systems. So the first question is, what's QSIG? Of course, it's Q signaling. It's one of the most fun acronyms where the acronym really means nothing. QSIG was a generic standard of signaling that was developed back in the PBX days. Now remember, PBX systems were heavily proprietary, right? But you eventually had enough PBX vendors and disparate systems where people are like, hey, we need some kind of level of interoperability. Like if I've got my Nortel PBX and I'm trying to talk to I don't know, Simmons or whatever kind of PBX system over here, we have to have some language where I can have a phone over here call a phone over here. And that's where they came up and developed QSIG. Q signaling, where the Q doesn't really stand for anything, as a generic language that PBX systems can use to interoperate. Well, now we are actually bringing up our voice over IP systems here, and there may still be legacy PBXs that we have to tie into. Well, the problem is there's no voice gateway that has the protocol standard of Q signaling. It was too big. It was a proprietary, well, not proprietary, but a PBX style thing. But the call agent can support Q signaling. So whereas H323 and SIP, they're kind of like, we don't get it. We can't speak QSIG because we're SIP and we're H323. What Cisco did is they put QSIG support on the call manager, and then by integrating this with MGCP, where this guy becomes a dumb terminal, we're able to support, for instance, linking a T1 to a PBX and communicating across that using Q signaling to where now these phones can call these phones and get features and a lot of the stuff that normally isn't supported using typical PBX connections. So MGCP is your protocol of choice for working with PBX systems. Now, some of you at this point may be thinking, I'm seeing advantages on all these. Like, H323, we've got the advantage of definite interoperability with every vendor. Like, everybody supports H323. It's a mature standard. But, SIP, I see some advantage of SIP trunking to maybe an ITSP. You see all the ITSPs out there. They don't do H323 trunks. They do SIP trunking with them. So I wouldn't use that. But now I've got QSIG. Maybe I want a little MGCP. Can I do them all? Sure you can. That's the beauty of these voice gateways. Just like in the old days, you could run a voice gateway, or not voice, but a gateway, that's where it got its name, that runs TCP/IP on one side and IPX/SPX on the other side, and that would now be a gateway or translator between those protocols. You can configure all three protocols on your gateway without issue. Now, MGCP is a little unique in that usually we deal with the gateway in terms of the voice gateway as a whole, right? Like you're on there, you're configuring SIP. You're like, okay, the voice gateway as a whole. If somebody dials this, you go that way, or use that voice port. You're doing that. But we're almost configuring the protocol in a global sense and seeing it as a whole. I know that sounds kind of I don't know, confusing to me even as I'm saying it, but let me relate it to how MGCP sees it, and it'll make sense. MGCP, when the call agent looks at the gateway, it doesn't see it in terms of a gateway. It sees it in terms of individual endpoints in that gateway. So for example, we'll say an FXS port 0/0/0. That is what MGCP sees as an endpoint. It says, okay, I see the voice gateway, but I only see it really as a catalyst to get to that FXS port. As in, this FXS port registers individually with that call agent. And then we've got, maybe a T1 line up here, T1 1/0. And that it sees it as like, okay, that's another individual registration. So when you go into the call manager, the CUCM server, and you look, it looks as if, maybe there's 8 individual endpoints on there, but they could all be a part of one gateway. So it looks like, oh, wow, I've got 8 gateways. No. MGCP just sees one gateway as 8 individual endpoints because of the ports assigned to them. Does that kind of make sense? So that's how MGCP operates. And then we start looking at MGCP as a stimulus response protocol. The way I think of it is it's almost like the military, where you've got, in the military, you've got the soldier and you've got the commanding officer, and the commanding officer is like, everybody, attention! And all the soldiers are, oh, yes, sir. They all stand right there. You have almost this command given by the officer, and then the response from all of the soldiers. He's like, drop and give me 20. Yes, sir. And he drops down and he gives them 20. Same kind of thing here. MGCP is just a list of commands. Like the call agent's like, create connection. Yes, sir. Modify your connection. Yes, sir. It's just kind of this stimulus response back and forth. Now, there's a series. I think there's 8 total commands of MGCP. I've put a couple of the key ones out there, but if you're really interested in all of them, you can look at it. For instance, like when this guy first registers, this guy will send an audit endpoint message and say, hey, I need to know what ports are on you, and the guy responds back and says, here's all my different ports, but of course uses the military verse, here's all my ports. So it responds back to that. But here's an example of what it might look like. This guy will send an RQNT message, and these are the actual message headers. So you could open Wireshark and see RQNT MGCP message being sent, and what that is a notification request. It's and what that's saying is, soldier, I should drop this analogy now, but I'm not going to. If anything happens on your voice port 1/0/0, tell me about it. I want to know. You watch that voice port, and the voice gateway says, absolutely, I will. And so notify messages are sent back in response to that. So what that means is the call agent is telling them, this is registered with me. If anything happens on that voice port, you tell me. You let me know. And so let's say this guy picks up and dials a phone number. He's going to notify the call agent saying, hey, something has happened. There's an event that has happened on that voice port. There's an event that's happened on that voice port. He dialed 9111111, which probably wouldn't be a good sample number. Let's use 9-800-111111, something like that. The call agent looks at that and is like, whoa, that's a dial pair. That's going to go out that voice T1 line, or that's going to go out to that voice over IP dial pair over there. Well, there wouldn't really be a voice. That's going to go to the call manager on the other side, or the SIP gateway. I mean, all of that is centralized in here. This guy has no idea where that call is going to go. So he's like, hey, he dialed this. He's going to reply back and say, create a connection. CRCX, you need to go create a connection over here to this voice gateway, or maybe over here to this call manager server. It depends on how you configure your dial plans in there. And he replies, yes, sir. He goes back and he goes and creates the connection. Now, meanwhile, this guy over here is like, whoa, I just got an incoming message on a port that was requested for notification. Hey, I've got an incoming call. Notify, you got NTFY. Incoming call. He's like, okay, you need to create a connection. CRCX. You see, do you kind of see how this is working? CRCX. You need to make that phone ring. He picks up the phone. He connects a message, and now we start getting this back and forth where he's reporting to his call agent, or I mean, these could be one and the same. I mean, maybe you don't have a call manager at this site. I'm just scribbling now. You don't have a call manager at this site. He's reporting back to this guy, so he's kind of, maybe the soldier now. It's just kind of a visual in my mind of Pinocchio or a puppet on strings. These guys are like routers on strings, where this guy is the string master. He's kind of like moving this router around however he wants to do it. If somebody needs to make a change, like maybe somebody puts a call on hold, temporarily terminate the call, a modify connection will be sent. And once this guy hangs up, he's going to be like, okay, delete the connection, DLCX, delete the connection. On this side, he's like, okay, delete the connection. So all of it, really just, a puppet on a string is all your routers become when you get them set up for MGCP. All right, let's look at the configuration of MGCP. There's not much to it, and rightly so. On a voice gateway, we shouldn't see too much. All of it's done in the call manager. So first thing that we need to do is get into global config mode and tell this gateway that it's going to be under the control of the call manager. So I'll type in CCM manager, which is the old, they'll probably never update the iOS to be CUCM, but CCM manager, MGCP says you will report to and use MGCP to be controlled by a call manager server. Okay, now we do the most forgotten command in this config, MGCP enter. You can type in all the other commands, and they look like they'll take, but nothing will work until you enable the protocol. Now we see an error message come up there because I don't have any IP addresses assigned. It's just a brand new gateway that I'm configuring. So we've got MGCP turned on. We see MGCP call agent is going to be what IP address of the call agent. So we'll just say 10.1 or 10.0.1. 10, whatever my fingers decide to type. So that's going to be the IP address of the call manager. We'll say service type, and then we'll choose MGCP. Notice there's some other protocols we can use that are MGCP variants, like SGCP was the very first edition before MGCP came out. Or we've got TGCP or NCS. Those are actually, they're specialized protocols for working with one specific type of equipment. It deals with something like DOCSIS networks, which is cable modem, and PSTN gateways. I've never personally used those sub-protocols, but they're there if you need to. And now the voice gateway is ready. So at this point, it's like 3 commands later, the voice gateway itself, the shell, is ready to go. But there's still one more thing to do. Remember I said MGCP identifies, or I should say the call agent identifies the gateway not as the gateway as a whole, but instead a series of endpoints. And the gateway, as you know, can use multiple protocols, SIP or H323, so it doesn't know which protocol you want to use for which port. So we have to go in there and identify to the gateway and let it know, I want you to use MGCP for this voice port or that T1 interface, or you get the idea. So the gateway has different ways of associating those ports depending on the type of port. Gotta love the consistency here. So if you've got analog ports like FXS, FXO, ENM, those kind of things, you're going to use this first command. Where's my pen? This first command right here. Application or service MGCP app. If you've got T1 or E1 lines, that's where these DS0 groups can come into play. Let me show you. I'm going to go on this gateway and I'll do a show voice port summary. A couple FXS ports. So let's say we want to put those under the control of the call manager. So I'm going to type in dial peer voice, and let's do whatever, POTS. Okay, I'm going to say this is going to be associated with port 1/0/0, which is an FXS port, and now I'm going to type in, depending on my iOS version, either application or service MGCP app. So how do you know which one? Well, if you type in application and it doesn't work, then service is probably the one you're going to use. Service is the later command. However, you'll see all kinds of documentation that still show the application. So if you're like, what? Why isn't that command working? It's service. Now, second question is it case sensitive? It depends. I haven't tested it on all iOS versions, but I know I have tried it on one where it wasn't working, and I was like, oh, I put it in lowercase. Let's try uppercase, and it started working. So I would say that it seems kind of squirrely. But it says right there all capitals. So how about we use all capitals? So I'll do service MGCP app and hit the enter key. That now associates that endpoint to MGCP. That's it. Now the gateway knows it is under control. When I respond to an audit request, I'm going to report that voice port is available and it's ready to be controlled by the call agent. Now on the T1, as a matter of fact, is this? No, I do. Okay. On the T1 controller, 1/0 I think is what it is. Yep. We use this command. Remember this is early on in the series. We created the DS0 group, so we can say, okay, group 0, or I'll use 1 because it's on the slide. Time slots 1 through 24. Type none, because the signaling is going to be controlled by the call agent. It will tell the gateway what kind of signaling to use. And then service MGCP. And enter, and now we've got this T1 line able to be configured and controlled by MGCP. Again, it's going to be reported as one of the endpoints that's available to the call manager. And that's the story of MGCP. I know, kind of anticlimactic, because it's not like we can see things work. It's not like H323 and SIP, where I'm like, oh yeah, go out and sign up for an ITSP and get your connection going from the gateway. I mean, it's just kind of like from the voice gateway perspective, we configure it for MGCP, and then the CIPT certified person comes in and does the rest all on the call manager. Now, so that's probably why, for me, from my perspective, I'm sitting here teaching it, I'm like, like I'm trying to bite my tongue because there's so much more to it, but there's so much more in the call manager. And that's why, of course, in the voice certification, CCNP voice, Cisco said, okay, call manager is going to be a big part of that. So all of that MGCP configuration is covered in there. And as a matter of fact, they even do a review in there of those commands, because obviously by the time you get there, you'll likely forget them if you haven't used them. But that is the MGC protocol in all its glory. I hope this has been informative for you, and I'd like to thank you for viewing.